In the last video, we were seeing about the general structure of the DNA of the model that was proposed by Watson and Crick. In this video, we'll be seeing about the molecular structure of DNA, followed by the base pair rule and the Chargaff's rule. To begin with, we all know the full form of DNA is deoxyribonucleic acid, which means the sugar that is actually present in the DNA is deoxyribose. And in the previous videos, we saw the structure of deoxyribose. So I've just drawn one structure of a deoxyribose. In this deoxyribose, to the first carbon is attached the nitrogenous base. Followed by that attachment, on the left side, you have the phosphate linkage. So we already know that the first carbon is being attached to the nitrogenous base and the fifth carbon is being attached to the phosphate linkage. And we also know that there is an HOH and one more H and H here. So we are not going to consider this, but we are going to talk about the HOH of this C bonded place here. Now this is just one sugar molecule. Now if you take another sugar molecule, the second one, again it is being attached to a nitrogenous base here and it is being attached to a phosphate linkage here. Now like this, a series of sugar molecules are actually forming in one strand of DNA. Now this is what is very important. In one strand of DNA, you will be finding a series of sugar molecules like this. Okay, how are these sugar molecules connected to each other? We'll see that. When you take these sugar molecules, what happens is the phosphate linkage of the sugar which is formed here along with the OH which is already there in the 3'. This is the third carbon. So to the third carbon, the OH is attached and the phosphate which is already attached to this sugar, both of them form a bond which is called as the phosphodiester bond. So this is very, very important. The phosphate molecule gets attached to the OH in the third carbon position which is here, and there is a bond that is formed which is called as the phosphodiester bond. In the same way, the phosphate 5 here, the fifth carbon, that again bonds with another OH of the previous sugar. So that forms another phosphodiester bond. In the same way, in this position at 3', there will be a phosphate linkage which is coming from the fifth carbon of the next sugar molecule, and that will form a phosphodiester bond. This is how a series of molecules are actually formed when you take one strand of DNA. Okay, now that I told, when the DNA is of one strand, this is how the series is formed. So we always know that the DNA, Watson and Crick model of DNA, is anti-parallel, which means when one runs from 5' to 3', the other runs from 3' to 5'. So when I have to draw the other strand, I just draw it the opposite way. I invert the sugar molecule, and when I invert the sugar molecule, my OH comes at the top, which means my 3' is at the top, and my phosphate linkage comes down. And you can find again there is a bond that is formed here, which is called as the phosphodiester bond. The same bond as this is formed here. In the same way, the phosphate here will be again bonding with the 3', and that will form a phosphodiester bond. This OH will bond with a 5' and that will form a phosphodiester bond. So this is how the series of sugar molecules are actually formed on one strand of DNA. Okay, now what about the nitrogenous bases then? We already saw that nitrogenous bases for purines and pyrimidines. So which will come here? A purine will come or a pyrimidine will come? Which is going to basically fall here? We'll see this. To know that, we need to understand the concept which is called as the base pair rule. So what is this base pair rule? The base pair rule very clearly tells that purines always bond with a pyrimidine, which means if there is going to be a purine here there will be a pyrimidine. Here if it is going to be pyrimidine, here is going to be a purine. So it is going to be alternative. As per the base pair rule, it is told that adenine always bonds with thymine and guanine always bonds with cytosine. So this is called as the base pair rule. Adenine always bonds with thymine and guanine always bonds with cytosine. So this is very, very important rule. And when this bond formation is taking place, if adenine and thymine are to be bonded, they are to be paired with each other. They are paired with the help of hydrogen bonds. And how many hydrogen bonds are formed between adenine and thymine? There are two hydrogen bonds formed between adenine and thymine, whereas between guanine and cytosine there are three hydrogen bonds. So when I just put this A, T, G, and C into this complex, now say for example, this is going to be adenine, the nitrogenous base in this place for this sugar molecule is going to be adenine, then I can be very sure on this position it is only going to be thymine, and the bond between them is going to be a double bond. And again in the next molecule, if it is going to be guanine here, then I can very well tell it is cytosine and it is going to be a triple bond. This is called as base pair rule. So it's a very simple structure. The only thing which we need to be very careful is the polarity. Polarity means 5' and 3', 3' and 5', that we should be very careful. So the free end, whichever is stated in the strand, that has to be left free. For example, 5' is left free here, the fifth carbon. So here the fifth carbon is free. And if you see the OH here, the third carbon is free, here also the third is free. So as per the strand, we need to design the molecular structure. Now going further, now let us go into a rule called as Chargaff's rule. The Chargaff's rule is a very simple rule. It's the same statement being repeated again and again. Adenine and thymine are equal in number. The first statement. We always know that because adenine always bears only with thymine. If there's going to be a thymine, there will be an adenine. And if there is an adenine, there is going to be a thymine. So there is no much difference in this. So the adenine and thymine are always equal in number. Second, the guanine and cytosine, they are also equal in number. So to put both these statements together, the purines and pyrimidines are equal in number. Or to put it very, very simple way, adenine by thymine is always equal to 1, and guanine and cytosine is always equal to 1. So this is the overview of the molecular structure of DNA, where you should know that the polarity is very, very important. And as per the base pair rule, adenine always pairs with thymine, guanine always pairs with cytosine. Adenine and thymine have two hydrogen bonds, guanine and cytosine have three hydrogen bonds, and the Chargaff's rule states the number of purines is always equal to the number of pyrimidines, and the ratio of adenine to thymine or guanine to cytosine is always 1. In the next video, we'll be seeing about the types of DNA.